So let's look at an example of the kind of problem that you're going to need to be able to solve. This question asks, at what points is the tangent to y equals 3 over the cube root of x parallel to x plus 16y plus 3 equals 0? So where should you start making sense of this question? I think the first thing you want to look at is you see this word tangent right here. And anytime you see the word tangent, you know that you are going to have to find the derivative of your function, because that derivative gives you the slope of the tangent. So that's probably a good place to start, and 95 out of 100 questions that you're going to see from the rest of the course are going to have the same starting point. You're going to be given a function, you're going to want to find the derivative. So it's always a good idea just to find the derivative of your function. So if we're going to find the derivative of this thing here, I think just like we did in those last examples, we're going to want to rewrite this a little bit. Instead of y equals 3 over the cube root of x, we're going to write this as y equals 3 times x to the negative 1/3. And that puts it in a form that makes it a little bit easier to take the derivative. Okay? So that cube root becomes the 3 from the cube root becomes the denominator in our fractional exponent. So we can go ahead here and we can find our derivative using those rules that we've learned. We're going to have the 3, we bring down the negative 1/3, keep the x, and then let's see, negative 1/3 minus 1 is going to be negative 4/3. So just multiplying this out gives us negative x to the negative 4/3 as our derivative. So remember, what is the derivative telling us, or what does it mean? It can give us the slope of the tangent to our original function. So this is our derivative function down here that at any x we want can tell us what the slope of the tangent to our original function, y equals 3 over cube root of x, is. Okay, what about the rest of the information that we're given in this question? Well, we're asked at what points is the tangent to this function parallel to this thing over here? Well, what is this the equation of? X plus 16y plus 3 equals 0. We saw things like this in vectors. What is this? This is just a line in standard form. Okay? So we're asked where our tangent, which is a line, is parallel to some other line. So if two lines are parallel to each other, what do you know about the equations of the lines? Or what do you know about the lines if they're parallel? What has to be the same, Shane? The same slopes. So I'll just say slopes same. So over here we've got a function that can tell us the slope of the tangent wherever we want it, and we want to compare the slope of the tangent to this function to the slope of this line over here. Now, this line isn't in a form that lets us get the slope very easily. So we should take this and we should rearrange it into y equals mx plus b form. Because if it's in that form, we'll know right away what the slope is. So let's do that rearranging here. I'll keep the 16y on one side. I'm going to bring everything else over to the other side. So I get 16y equals negative x minus 3. So y equals, divide everything by 16, negative 1 over 16x minus 3 over 16. So what is the slope of this line? The slope here is negative 1 over 16. So if I'm trying to find where the tangent to this curve is parallel to this line, I need to find what value of x is going to make the slope of the tangent from this derivative equal to negative 1 over 16. So I've got to take these two expressions for my slopes that I've set are equal because our tangent and our line are parallel, and I'm just going to set them equal to each other. And now I've got an equation that I have to solve here. How do I solve this equation? Any thoughts? Malcolm? There's one thing we can do right away. We've got a negative on both sides, so we can get rid of the negatives. So I'm going to make this 1 over 16. The other thing that I'm going to do is we've got a negative exponent on the left-hand side, so I am going to take that negative exponent and I'm going to get rid of it and move my x to the 4/3 down to the denominator. Okay. Now things are starting to look a little bit different. What do you think we might do from here to solve? We got 1 over something on one side. We got a fraction on one side, a fraction on the other side. Yeah. We can think of, imagine we've just sort of cross-multiplied there, or just that if these two fractions are going to equal, they got the same thing on the top, they got to have the same thing on the bottom. So we've got 16 equals x to the power of 4/3. How can we solve this from here? Amy? So take both sides and raise them to the exponent 3 over 4. That'll work. Okay. What's that going to do? Well, on the right-hand side, if we've got a power to another power, we multiply the exponents together. We're going to get 1 over 1, which is going to leave us with x. And over here, we're going to have x to the 3 over 4. Now what is, 16 to the 3 over 4. Now what is 16 to the 3 over 4? Actually, I've skipped over a tiny little detail right here. Okay. On the right-hand side, I've got x to the power of 4 over 3. So I've got to think of that, I'll write this in green as x to the power of 4, and we're taking the cube root. Okay. So if I have this x to the power of 4 over here, that's an even exponent, right? So that means my solutions can be either positive or negative, whatever number I get over here. Because if I put a positive number in here for x and I take it to the power of 4, I get a positive. If I put a negative in here for x and I take it to the power of 4, I get a positive as well. Okay, so we're going to see this a bunch, where if you've got something like x squared, you're going to get two solutions, a positive solution and a negative solution. Okay, now what is our numerical value here for 16 to the power of 3 to the power of 3 over 4? McKenna, you were going to give us the answer there. 8. It's 8. Okay, so x is equal to positive or negative 8. Now, does it make sense that we have two values of x here? Well, if we go back up to the original question, it did say at what points, plural, is the tangent parallel. So the fact that we've gotten two answers is consistent with the way the question is asked. We're going to end up with 2 points here. Do we have 2 points? Well, we don't actually have points yet. All we have right now are x values. So if we want to get points, we have to take our two x values and sub them into our original function. So we're going to take these two things. Our original function was y equals 3 over the cube root of x. And we're just going to sub them in. So where x equals 8, y is going to equal, let's see, 3 over the cube root of 8. The cube root of 8 is just 2. So we get 3 over 2. And if x is equal to negative 8, y equals 3 over the cube root of negative 8. Wait, I'm taking the cube root of a negative number. Is that bad? Some of you are nodding. But I'm tricky. Sometimes I try to fool you with stuff like this. Can we take the cube root of a negative number? We can't take the square root of a negative number, right? Because that would mean that two numbers multiplied together would have to give us a negative, and that's not going to work. But can we take the cube root of a negative number? Liam?
Yes.
Yes, we can. Odd roots, we can take the odd root of a negative number. We can't take the even root of a negative number. So this is 3 over negative 2. Negative 2 times negative 2 times negative 2 gives us negative 8. Okay? So, therefore, the points are, what did we have? We had 8 3/2 and negative 8 negative 3/2. So if you're wondering what all of this would mean graphically, the function will look kind of like this. X, Y, it has one branch like this. It has another branch like this. Okay? And we can imagine that we've got a point here and a point over here, where if we construct the tangent to the curve at these 2 points, that one's going to have a tangent like that. That one's going to have a tangent like that. So the tangent to the curve, there are 2 points where those 2 tangents are parallel. And then we've got, I think, what was this other line? It was negative 1 over 16. Yeah. So then our third line, this was the line that we were given in the question. X plus 16y plus 3 equals 0. So 2 points on our curve here where our tangent is parallel to this line that we were given in the question.